Greetings from Key Largo, Florida. I'm in my production studio with my editor, beautiful Lauren Bacall, and welcome to this presentation on applications of equations with parentheses, where we'll also introduce the concept of systems of equations. Let's start with a little review. Back in the first grade, you were introduced to addition. Here's an example. Perhaps they taught you to split that 23 into 20, add 3, and then write the add 4 right below it. You would have 3 add 4 was 7. There were no tens places. So you bring down the 20 and the addition, and you would get 27. By the time you got to the third grade, they had introduced geometric figures like this pentagon. Penta means 5, 1, 2, 3, 4, 5 sides. And they were using that as an application for addition. And they introduced a term called perimeter. And the perimeter was how far it was around that geometric figure. And to get that, you added all the sides. And in this case, that was going to be 4, add 4, add 5, add 5, add 3. I don't know exactly how they taught you to do that, but something my grandfather taught me when I was where third graders typically are. He had me write things like this, and then he just did it stepwise. That's 8. That's 10. And that's 3. 18 and 3 gave me 21. A little bit further into the third grade, they gave you something like this, talking a little bit about subtraction now. And they said the perimeter was 21. They gave you the perimeter and wanted you to calculate the unknown side, and they used a question mark perhaps, and then add 4, add 4, add 5, add 3, and then they had you do this, add the 4s, add the 5 and the 3, still the question mark, 8 and 8 comes out to 16. And then they taught you just to subtract this 16 from the 21. What we've been doing is the additive inverse. I'm sure they didn't teach you that in the third grade. Those cancel out. 21 subtract 16 was 5. But one of the things that we've seen here in the 8th grade, that these are similar terms. And that to solve this equation, one of the first things that we want to do is combine similar terms. That's what we did in these steps here. Right? And for us in the 8th grade, we know now that to isolate this unknown, that we had to zero this guy out. That's called the additive inverse. You were doing those things in the 3rd grade, even though they didn't give you the formal names for what you were doing, but you were doing exactly the same thing that we're doing here. By the time you got to the 4th grade, they were introducing the concept of formulas, especially for rectangles and squares, and still working with perimeter. They said perimeter equals 2 times L plus 2 times the width. We know that in a rectangle that this side equals this side and this side equals this side. So we have two sides of the length, and we have 2 times the width. We have one here and one here. And we wrote it like this. Then they would say that L equals 5 and width equals 3. And even though they didn't say this, it was true at the time. Whenever you have something like this is called a system of equations. A system of equations. And the way that we solve this is just to substitute these values for L into this formula. And that would look like this. Wherever I see an L, I'm going to put a 5. So it would be 2 times 5 plus 2 times W, which is 3, and that equals the perimeter. At this point, we only have one equation and one unknown. In this equation, we had one equation and 3 unknowns, and we got it down to one equation and one unknown by doing the substitution. They didn't tell you those things, but you were doing that back in the 4th grade. And then we just do the arithmetic. 2 times 5 is 10. Add 2 times 3 is 6. That equals the perimeter. Now we have these similar terms. You know that we need to combine similar terms. It was 16 equals perimeter, and we box that in. By the time you got to the 7th grade, you still had the same formulas. P equals 2 times the length, add 2 times the width. But in this case, instead of calculating the perimeter, they gave you the perimeter. And in this case, we gave you the width. Once again, this is a system of equations. In the original formula, we have 3 unknowns, and we have one equation. To be able to solve this, we need one equation and one unknown. So in the 7th grade, you substituted the value of P into the formula, and that would give you 16 equals, we don't have a value for L, and that was going to be 2 times L plus 2 times 3 is the width. And you step through this, and that became 2L plus 6 equals 16. Now we have one equation and one unknown. You know how to solve this from what we've done earlier in the semester. We're going to add the opposite of that positive 6. Do the same thing on the other side of the equation. And we have 2L left there on the left-hand side of the equation. That gives me 10. Now we have 2L equals 10. This is a multiplication. To solve that multiplication, we're going to multiply by the multiplicative inverse, or the reciprocal of this number, which is 1/2. Multiply both sides by 1/2. The reason we multiply by the reciprocal is to get a 1 on this side, and then 10 divided by 2 equals 2 times 5 divided by 2. The 2's cancel out, and we're left with L equals 5. That's all the review. Now let's move on to the 8th grade. Beam us up, Scotty. We now have this situation, and we're given an expression for the length, and we're given an expression for the width. And in this case, I'm going to say that the perimeter equals 152. And what we want to do is solve for L and W. We have the equation, the formula, P equals 2 times the length, add 2 times the width. And then we have these values, these expressions for L. We have L equals 3x, add 2. And the width equals 2x, subtract 6. All of this up here is called a system of equations. And we'll use all of that together to solve first for x, and then we'll take whatever value of x we got and put back into the equations for length and width. So here's the strategy. I'll just write IW. I will write the formula. And the formula is P equals 2 times the length plus 2 times the width. I will substitute all the other information that I know. We were given that the perimeter is 152. That 2 is a constant. Now I'll substitute the expression for L, open parentheses, 3x plus 2, add 2 times the expression for width, next step, I will distribute and what I mean by that is to multiply everything inside the parentheses by this leading coefficient. I always like to draw these golden arches to remind myself to multiply everything inside the parentheses by that coefficient. When I do that, I'll bring down the 152 and the equal sign. 2 times 3x gives me 6x. 2 times 2 is a 4. Bring down that addition sign. Then 2 times 2x is 4x. And then 2 times negative 6 is negative 12. Notice that we have similar terms on this side of the equation. We have x terms and we have number terms. So the next thing to do, I will combine like terms. Bring down 152 equals. I'll rearrange this side of the equation. 6x, add 4x, add 4, subtract 12, I'm at this point now. I'm going to continue simplifying. It looks like this. I'm going to factor out this x from these two like terms. Gives me 6, add 4, in parentheses, times 4. And I can just do this addition here. That's going to be negative 8. Continuing on, it's going to be 10x subtract 8, and that equals 152. At this point, the equation is simplified down as far as it can. I don't have any similar terms on any side of the equation. We know how to solve this now. I will zero out the negative 8. And the way I do that is to add the opposite. I'll do the same thing on this side of the equation. This gives me 160 equals 10x. I will use multiplicative inverse. When I get to this point, what I like to do is put everything over 1 because I know I'm going to multiply by a fraction. I'm going to multiply by the reciprocal of 10 over 1. I'll multiply this side by 1 over 10. This leaves me with x. And then 160 divided by 10 is 16. That's an intermediate value. Remember, the question asked to solve for the length of each side. This x goes into the expressions for the length of each side. So I'll be using that now to calculate the length of each side. So we've got that, x equals 16. X equals 16. And we have length equals 3x add 2, and width equals 2x subtract 6. Recognize this as a system. I will calculate length. So we write the equation. L equals 3x add 2. We'll now substitute that value of x into this equation. Equals 3 times 16 add 2. That equals 48 add 2. L equals 50. I will calculate the width. So the width equals 2x subtract 6. We'll substitute this value of 16 into this equation. That gives us 2 times 16 subtract 6. 2 times 16 is 32. Bring down the minus 6. Width equals 26. So at this point, I have the length equals 50 and the width equals 26. And I still have perimeter equals 2 times the length plus 2 times the width. This is a system of equations. At this point, we've calculated the values for the length and the width, so I will check my work. So I know that from the given problem statement that the perimeter equals 150. That's going to be 2L add 2W. Now I'll substitute the values for L into this equation. That equals 2 times 50. Add 2 times the width, and the width is 26. 2 times 50 is 100. 2 times 26 is 52. 152 equals 152. That's a true statement. Just assuming that I haven't made any errors that canceled out. It looks like I've done everything perfectly. One of the things that helped me step through this was writing down my strategy as we work through the problem. Helps me slow myself down, helps me organize my thoughts. It doesn't guarantee that you won't make mistakes, but it will limit the number of mistakes that you do make. So there's only one thing left to say after all of that, and that is, that's all, folks. Thanks for watching. Thanks for learning. Stay safe. Con cuidado.